we're going to have a look at a couple more equations. And these are going to be equations which have got fractions and negatives and other funny stuff in them, just so that we don't get fazed by equations that have fractions and other funny stuff in them. So here let's go back to kind of a really pretty nice equation, which is something like 3x is equal to 15. We know how to solve these by now, right? We want to get x on its own, so we've got to divide by 3. What we do to one side, we must do to the other side of the equation. So we're dividing both sides by 3, and we get x is equal to 5. All very pretty, nice whole number. If you have something like this, 7x is equal to 5, process is exactly the same. You want to get x on its own, so you have to divide by 7. And what you do to one side, you must do to the other. So we're going to divide both sides of the equation by 7. On the left, we get what we wanted, x on its own. But on the right, we've got to do 5 divided by 7. And that actually, it doesn't come out to a nice whole number. Does not matter. We've got an answer there. The answer is just 5/7. It's perfectly fine to have a fraction as an answer to an equation. And we can even get fractions in the equation. So we could be asked to solve something like x plus a half is equal to 2/3. Same process as we've dealt with whole numbers. We've got to get x by itself, so we need to subtract a half. What we do to one side, we must do to the other. Okay, so the left works out really nicely. X plus a half minus half obviously just gets us to x, which is what we wanted. Now we've got to work out what 2/3 subtract a half is. If you've got a calculator, and you can just go ahead and use the calculator, but let's just do a quick reminder of how we do subtraction with fractions. First thing we need to do is we have to have a common denominator. We can't have the thirds and the halves, right? We've got to have them with the same denominator. To do that, we look at what the lowest common multiple of 3 and 2 is, and that is 6. So we use 6 as the common denominator. So what we're going to get is 4/6 minus 3/6. That's because 2/3 is the same as 4/6. We multiplied 3 by 2 to get to 6, so we must multiply the 2 by 2. And a half is the same as 3/6 because we multiplied 2 by 3 to get to 6, so we must multiply the 1 by 3. And now it's nice and easy to do the subtraction because we've got a common denominator. So 4/6 minus 3/6 is 1/6. And so we've solved our equation. X is equal to 1/6. All right, let's have a look at another two equations. First one, negative x is equal to 2. That one, hopefully you can immediately think about. If negative x is 2, then x should just be negative 2, right? But if you couldn't think that through and you needed to go through it slowly, remember, what does negative x mean? It's just negative 1x. So what we can then do is just divide both sides of the equation by negative 1. And on the left we'll get an x, and on the right we've got 2 divided by negative 1. A positive divided by a negative is a negative, and 2 divided by 1 is 2. So our answer is x is negative 2. The very last one has got a whole lot of mess to it. The first thing is that we've got the x on the right-hand side. Now that's fine, we can leave it there and just go ahead and deal with it on the right-hand side. But if you don't like it on the right-hand side, it's fine. You can just start by swapping it around. These two things say exactly the same. Negative 3 is equal to x over negative 7 is exactly the same as saying x over negative 7 equals negative 3. So you can just swap it to make it look as you normally have it with the x's on the left. We now want to get x on its own, and it's being divided by negative 7, so we have to multiply it by negative 7 to get it on its own, and so we need to do that to the other side of the equation too. Alright, so on the left we're going to just get x, and on the right we've got negative 3 times negative 7. Negative times a negative is positive, 3 times 7 is 21, and so we get our answer for x is 21. We're going to start working towards solving two-step equations. But first we need to be very sure that we can read an expression that involves two steps. Let's have a look at something like this. Here we have an equation that says x over 3 plus 4 is equal to 9. What does this mean? Well, we start by taking a number x. What's the first thing we do to that x? Well, the first thing is that we're going to be dividing it by 3. And then after we've done that, we then do the next step, which is to add 4. And finally, we say then we get our answer of 9. Now we know that the order in which things have been done to x is divide 3, then add 4. We can then go about solving for x by simply reversing the process, looking for the inverse operations. So what we need to do is, firstly, we need to subtract the 4. And we'll get 5. And then we need to multiply by 3. And we'll get our solution that x is equal to 15. Looking at a different example, here again we say we're going to start with x. So if I take some number x, what's the first thing we're doing to x? Well, in this case, the first thing that we're doing is adding 4. After we've added 4 to x, then we divide that whole thing by 3. And finally, we get our answer of 9. Now I know the order in which things are done, I can simply work backwards to undo the things that have been done in order to work out the solution. So I use my inverse operations. So first, I need to multiply by 3. And that will give me that x plus 4 is now 27. Then I need to subtract 4, and I'll get my solution to the equation, x is equal to 23. Let's look a little further at solving two-step equations. Let's have a look at this equation. If we're trying to solve the equation, what we're wanting to do is get x on its own. So because we have 3 multiplied by x plus 6 on the left-hand side, to get rid of that 3, we need to do the reverse of multiplying, which is dividing. And what we do to one side, we must do to the other, and then we will get that x plus 6 is equal to 8. We still haven't got x on its own, so we need to work further. And here we need to find the inverse of adding 6, which of course is subtracting 6. And what we do to one side of an equation, we must do to the other. And so we will get our solution, x is equal to 2. Okay, here's another one. We want to solve for y, so we want to get y on its own. So the first thing we want to do is get rid of that 2. So we're going to subtract 2 on the left, but obviously with an equation, what we do to the left, we also need to do to the right. Here we're going to have 2 subtract y, subtract 2. Well, the 2 subtract 2 gives us nothing, so we're going to be left with negative y is equal to 1. Now we haven't got y on its own, we've got negative y. But if negative y is 1, we know the very next step is to say y is equal to negative 1. We're going to do a couple more examples of two-step equations, ones that have got lots of negative numbers all over the place. Okay, if we're faced with a monster like this, no need to panic. We want to solve for t, so we want to get t all on its own. So we first need to have a look at what we need to do to get rid of this. Well, we've got a negative 6. To get rid of it, we're going to add 6. And what we do to one side of the equation, we must do to the other. So what we're going to have on the left, well, the negative 6 plus 6 is going to just give us 0, and we'll have t over 7. Negative 5 plus 6, we know that that's going to end up as positive, and it's going to be positive 1. Negative 5 going up 6 steps ends us up at 1. Now we're still aiming to get t on its own, and so what we need to do here, because we were dividing by 7, we need to do the inverse, multiplied by 7, and we will get that t is equal to 7. Another example. Here we want to solve for y. First thing we need to do is to get rid of this negative 9. It's being divided by negative 9, so to get rid of it, we need to multiply by negative 9. And if we do that to that side of the equation, we must do it to the other. So multiplying by negative 9 here will just leave us with y minus 8. And then negative 7 times negative 9. A negative times a negative is a positive, and a 7 times 9 is 63. Okay, and now we're almost done. We want to get y on its own, so we need to add 8 on this side. What we do to one side of the equation we must do to the other, and we'll end up with the answer y is equal to 71. And let's finish off by looking at a monster that has negative numbers and fractions in it. Again, if we just go step by step, we can get there. Here we're wanting to solve for x. So the very first thing we need to do is get rid of this, subtracting a half, and what we need to do that obviously is to add a half. So what we will get is that we will get negative 2x is equal to negative a quarter plus a half. Now, negative quarter plus a half is just the same as a half. Subtract a quarter. Common denominator of 4, so we've got a half is 2 over 4, subtract 1 over 4, and we're going to get our answer of 1 over 4. So we've got negative 2x is equal to 1 over 4. Now we need to get rid of that negative 2, and it's negative 2 multiplied by x, so we need to divide. And so on this side we need to divide by negative 2. And I don't want to put a fraction over a fraction, so I'm actually just going to write it as divide by negative 2. So here I've got x. Here I've got a quarter divided by negative 2, which is just negative 2 over 1. We know how to do that. It says the same as multiply by 1 over negative 2. And so what we'll get here, 1 times 1 is 1, and 4 times negative 2 is negative 8. So our answer is, our solution to the equation is x is equal to negative 1/8. We're now going to look at some equations that you need to solve where the variable, the x, is on both sides of the equation. Let's have a look at a scenario where the number of sweets over here is exactly the same as the number of sweets over there, and we want to keep it like that. The number of sweets in each box is exactly the same, and we're trying to figure out how many sweets are in the box. We can represent this situation by an equation. If we think of x as being the number of sweets in the box, then what we have is x sweets and another x sweets here. So x and x is 2x plus 3 spare sweets. And then over here, what we have is x sweets and then the 13 sweets that are lying around. Now, we want to figure out how many sweets are in a box. So what I'm going to do is I'm going to keep doing whatever I do here, I'm going to do here, so we keep the number of sweets over here and the number of sweets over here the same as each other. So we keep the balance. And I'm going to work to just getting a box, one box alone over here, and just having loose sweets over there. So the first thing I'm going to do is I'm going to take the sweets out of here. But if I take 3 sweets out of here, of course, to keep it balanced, I must take 3 sweets out of there. In terms of the equation, that is what I have done. We still have exactly the same number of sweets on each side. In terms of my equation, what I have now is that 2x is equal to x plus 10. Okay, the next thing I'm going to do is, because I actually don't want any boxes left over here, so what I'm going to do is I'm going to take the box out here, and then I must take the box out there to keep it balanced. In terms of my equations, I've taken x sweets out of the one side and x sweets out of the other side. What do I have left then? I've got 2x minus x, which is just x, and over here I've got 10, showing me that one box of x sweets is equal to 10 sweets. So this is the process of solving an equation where you've got x's on both sides. Your aim is to get just x's on this side and just numbers on that side. We'll look at a couple more examples of how to do that. Let's have a look at solving 2 more equations. If we ask to solve 11x plus 5 is equal to 2x plus 9, remember, what we're trying to do is just get x's alone on this side and numbers alone on that side. So let's first get rid of this plus 5. We can do that by subtracting 5, but of course, in order to keep things balanced, what we do to one side, we must do to the other side of the equation. Now we want to get rid of x's on the right, so let's get rid of this 2x on the right. And the way we can do that is to subtract 2x on the right. But if we subtract it on the right, we must do the same on the left to keep things balanced. So we will get that 9x is 4, and of course we just want x on its own. So we divide both sides of the equation by 9, and we'll get that x is 4/9. If we ask to solve an equation like this one, there's just one extra step to do, and that is we need to multiply this out so we get it back into this sort of a state. And remember, we have to use our distributive law to multiply out. So the 6 must multiply with the x and also with the -2, and the 5 must multiply with the x and with the 2. Now we're in the same situation as before. We want to get x's alone on this side, numbers alone on that side. So let's first start by getting rid of the -12, and we'll do that by adding 12. And so what we'll get is that 6x is 5x plus 22. We want to get rid of the x's on the right, so we'll subtract 5x on the right. Keeping it balanced means we'll get x is equal to 22. Let's go through a few more examples of solving equations with x on both sides. Remember, as always, our aim is to get x's alone over here and numbers alone over here. So, because we wanted to get x's alone over here, let's get rid of that 7, and of course, balancing our equation means that we must do the same on the other side. 2 subtract 7 is -5, and so we have that picture. Now, remember, we're wanting to get rid of the x's on this side. So in order to get rid of the x's, we've got take away 9x, so we're going to add 9x, and if we do it to one side, we have to do it to the other side. And so what we'll get is 11x is equal to -5. And now it's very easy to complete. We just divide both sides by 11 and we get our answer -5/11. For this one, we're aiming at exactly the same thing. X's on this side, numbers alone on that side. So we're going to start by getting rid of that 3 and balancing the equation. We must do it on the other side too. 1 subtract 3 is going to be -2. And so we've got -2x is equal to x minus 2. Remember, we want to get rid of the x's on this side. So we're going to subtract off this x. And we must do the same on this side to keep things balanced. And so we're going to get -3x, because -2x, subtract another x is -3x, is equal to -2. And now we just divide both sides by -3 to get x on its own. A negative over a negative is a positive, and so our answer is just x is 2/3. Okay, a final example. Again, we want to get x's on its own over there and numbers on our own over there. So what we're going to do is get rid of the 17, balance the equation, and so what we're going to get, 7 minus 17 is -10. And now we want to get rid of the x's on this side. We're subtracting 3x, so in order to get rid of it, we must add 3x, and of course balance the equation. -10x plus 3x gets us to -7x, and here we've got it equal to -10. We want x on its own, so we need to divide this side by -7, and of course balance it, do the same to the other side. Negative over negative is positive, and so we've got x is equal to 10/7.